Hi, everyone. Mike Hamilton. I'm with Peraso. And so Peraso is, let's see if I can make this work. Here we go. So you may wonder why Peraso is here talking to you. We are a fabless semiconductor company, and we also build modules. And the reason that I'm here is because 60 gigahertz is the reason that Peraso was founded. We were fundamental in the establishment of the original WiGig form and then the writing of the standards, the IEEE 802.11ad and later the 802.11ay. And we were also one of the first companies in 60 gigahertz to really realize that a real use case for it is in fixed wireless access. So we've been doing the fixed wireless access angle on 60 gig and introducing new chipsets and software to fit that market for longer than anyone else. And I think you know that today that technology has made its way into several product lines, including that from Ubiquiti and a few other vendors, and we've gotten really good response in the last couple of years since those latest products have been rolled out. And our products are differentiated from some of the other 60 gigahertz that's out there. I'll go into that a little bit, and I'll also talk about just the general 60 gigahertz evolution and the technology that's involved. Um, the thing that I think we always want to look at, and I'm sure that everyone is here because they believe that fixed wireless access really does make sense to provide broadband service to customers. There's a lot of competition out there. Obviously, fiber is right now what is being pushed by a lot of carriers, and even the customers are out there demanding they want fiber capability and fiber capacity. But I think what they're really saying is that they want broadband. You know, they're tired. Underserved communities are tired of having either being overlooked or getting underserviced. And they don't like the weight that it takes to bring fiber into those communities. And in some places, there are topographical challenges and distances that are just not feasible to lay fiber that distance. And so wireless really does make sense. And the recent wireless technologies can truly provide broadband, and that doesn't just mean 100 megabits per second. I mean, gigabit per second, true gigabit symmetric capabilities are there, and 60 gigahertz is the way to get there. 60 gigahertz has additional advantages, and of course, it's an unlicensed band, so anybody can install it and build equipment for it. There is 14 gigahertz of contiguous spectrum available in the North America. That's a huge amount of spectrum, way more than all of the Wi-Fi and everything else put together. So making intelligent use of that spectrum is really the way to go for a lot of applications. Another benefit, 60 gigahertz, we're at 10 times the frequency of Wi-Fi. So there's no interference. There shouldn't be any interference from the Wi-Fi signals to the 60 gig or the 60 gig back to the Wi-Fi. So in congested areas where everyone's got their home routers and APs, there's capability there to distribute the broadband data without worrying about interference from the other guys. And also without having to employ super high-tech, interference reduction technologies and beam notching and all this kind of stuff that you see being done in other frequencies. 60 gigahertz is basically riding above all of that at a frequency band that no one else is touching. I'll get into some of the features of the hardware. We have low power consumption, easy to install hardware that's it's readily available. We have flexible system features that are partially developed by Peraso and also partially developed by the system vendors that are employing our chipsets. So I think through this session, I'll give you that broad overview, and at the end or during the meeting, you can ask questions or clarifications on that. One thing I like to compare the old adage of you can get technology that's good, cheap, or fast, and you can pick any two. And I argue that these days that fiber is definitely good, but it's neither cheap nor fast. So you've got wireless, on the other hand, is firing on all cylinders and is good, it's cheap, and it's fast. So I think it's a technology we need to examine a little more closely. Let's compare to 60 gigahertz quickly to other WISP oriented frequency bands. Of course, fiber we've just talked about. 2.4 gigahertz Wi-Fi is widely deployed for access, and also the 5.8 gigahertz Wi-Fi. I would say that it's becoming clear through anyone that's really worked with these in dense areas that congestion and interference can be a major problem. Um, it's very unpredictable what kind of service you'll be able to get because of that interference. And proprietary technologies such as that by say Tirana have been developed using the same frequency bands, but they've employed powerful DSP to combat that interference. But that powerful DSP comes at a very price of both power consumption and very high cost for both the CPE, customer premise equipment, and um, for the access points. There's a lot of products that are out there from 6 to 18 gigahertz. These are not exactly license free, but they're, you have to take care of um, frequency coordination and light license fees, but they're generally only used for point to point and not for point to multi-point. 60 gigahertz is very high bandwidth. The hardware costs, as you can look at the vendors, are very low. Both the access points and the customer premise equipment can be very attractive in pricing. There is the issue that we have to face, which is that it is line of sight propagation. That's the physics of 60 gigahertz. That pretty much you have to provision your links with line of sight. But there are techniques of doing bridging and building mesh networks that are feasible and do allow you to overcome most installation hurdles. And finally, I mentioned 70 to 80 gigahertz. This is a great technology for backhaul. It's not cheap, but it does provide also a lot of bandwidth and is good for point-to-point backhaul installations. So there's a number of vendors out there. You guys are probably familiar with quite a few of them. Ubiquiti, of course, is a huge vendor of all kinds of both Wi-Fi and 60 gigahertz technology. The other guys here are familiar to you through Streakwave. You also see that there's been some industry consolidation recently where Ceragon has acquired Ciclu. So we'll see where their consolidation leads in terms of their product direction for the future. And I encourage you to, do your research and look at each of these vendors and see what they've got available. And you can see, which ones have the 60 gigahertz capabilities and what feature sets that they offer. And we'll get into a little bit of that differentiation in a minute. When you're evaluating different technologies to use, I think everyone does their own return on investment calculations. And I'm not here to try to tell you that there's a perfect way to do return on investment calculation, because each scenario, dense, urban, suburban, rural, each one of those is going to come up with a different set of considerations. Of course, you're going to look at your direct costs, which is going to be the cost of your AP, your subscriber stations, how much it costs to lease the tower, power consumption, and all your installation labor. But then there's going to be other weighting factors you have to consider, which go beyond just the direct cost. You need to really understand what your model is for how fast you're going to be able to bring on subscribers and how much, and that's going to influence how much you're willing to invest in your initial access point. Let's say your initial access point costs. In some areas, you may not expect to get a lot of subscribers, so you're not going to want to spend a $20,000 access point to get 5 subscribers. You're gonna need to get a lower cost AP that can provide good service for that lower density of subscribers. You need to consider if the area that you're looking at has Wi-Fi interference, and if that's going to be a blocking factor. And you're going to have your own experience of what really works. Talking to your other operators and figuring out whose hardware and what equipment is really delivering on their promises is, I think, one of the best ways through word of mouth to decide what works. I've done a few case studies that I'll share with you. These are all based on real world, but what I'm showing you are not exactly real installations. But the first one I'll start off with is like a suburban neighborhood. This one I took a area of about just under 200 acres in space, where there's around 900 homes. And I assumed we'd want to target about 25% penetration, because this is an area that's already got cable, it's already got 5G coverage. So the customers already have service, but you're trying to penetrate this area and get some wireless customers on that. And the target is to get, say, let's get 25% or around 225 homes. And in order to do that, I'm lining up here in this table a comparison of what it would take to do that with 60 gigahertz versus Wi-Fi 6E versus a Tirana G1 system. So, and just quickly looking at the 60 gigahertz, it would require 12 access points to cover that number of homes in this kind of area. So the access points in 60 gigahertz can support, say, currently up to 24 client subscribers. That's on the Ubiquiti Wave system. And the total aggregated bandwidth for that number of access points is 36 gigabits, which is very high, of course. And if you just do a division of the 36 gigabit by 225 homes, that's, a worst case of 160 megabits per subscriber. And of course, the peak data rates that the subscribers could see would be up to a gigabit per second bidirectional, because the technology supports 2 gigabits per second in MCS9 mode. And the cost for those access points would be about $6,000. And of course, that doesn't include installation and tower costs. In Wi-Fi 6E, to get the same coverage of 225 customers, you could do it with 2 or 4 access points, and you'd be in the same kind of price range, around $4,000 to $8,000. But your total aggregated bandwidth is only going to be up to 28 gigabits per second. So you're looking at 64 gigabits and much lower peak speeds for those users. And in the Tirana system, their throughput per access point is actually even lower. So you can do it with 1 access point, because they support a large number of users with 1 access point, but you're only at 2.4 gigabits per second. And that's 11 megabits per second, 11 megabits per second per customer. And that's at a premium price. I'm not sure exactly of the pricing, but I've heard it can be as low as $12K for their access points and 2 APs at $24K. Definitely a much bigger investment in order to get those customers. So the 60 gig allows you the ability, we mentioned 12 APs, and that's a large number of APs, but it's really giving you the ability to scale as you grow. You can install a lesser number of APs to get started, and as your customer base grows, you're able to expand the access points to match the customer load. On the other side of the situation would be more of an urban environment, where you have very low density of installations. In Midwest farmland, basically you have one homestead farm for every square mile. And 3 access points could cover 16 homes, but those 3 access points are only costing $1,500. So the return on that investment for 3 APs can be quite fast at a reasonable subscriber rate. Also, the cost of installation can be managed. I know a number of operators that are using grain silos as their towers. And so there's power there. They're stable. You can set them up easily, and they don't really charge any rent for that. So you can get the coverage and distribution fairly easily. And then you can set up either a 60 gigahertz or maybe a 70, 80 gigahertz as a backhaul link, and build a network out that way to service these remote areas. And the competition is, well, you could go to Starlink. That's a fairly expensive solution, so you can be competitive with them on cost. There's not going to be good 4G, 5G coverage out there, or LTE coverage. And Wi-Fi fixed wireless is a possibility, but you're going to have lower throughput and higher latencies on a Wi-Fi solution. So it's generally not really a preferred solution for most customers once they see what the user experience is like over a Wi-Fi. There's often a lot of negative feedback on that. Another area that we're deploying 60 gigahertz into is in RV parks and mobile home parks. And here it's a really interesting use case because you're very dense. You've got mobile homes that are side by side, but there's nothing tall, there's nothing in the way. So you're able to put up a tower and cover a whole lot of these users very quickly, and for their very low cost, giving them very high quality service, basically setting up 4 or maybe 6 access points around the property, beaming the signal down to each customer. And there's very little interference here because the narrow beam of the 60 gigahertz antennas, prevents co-channel interference. And you're not, and the Wi-Fi that everyone's got inside their mobile home or RV is also, again, not interfering with the 60 gigahertz. So it's a really good solution for these kind of high density environments. You can extend this to high density urban areas where you have a lot of multi-tenant unit housing packed together. It could be applied in the same way. So Peraso offers a variety of antenna solutions built into our modules. And then on top of that, you'll see vendors, the system vendors adding a dish for even more focused beam, very narrow beam control of the signal. So I think if any of you are subscribed to Wisp Talk on Facebook, I participate in that occasionally, and I've seen a lot of good feedback there from some of the WISPs that have been using Ubiquity and other equipment that's based on Peraso's chipsets. Got a couple of quotes here from GigFire and Cobalt Ridge. They've been good partners with us, and we've learned a lot from the correspondence with these guys and with everybody else to really help us improve what we're doing as a chipset vendor, and hopefully meeting your guys' needs in the field. So now that I've kind of covered some of the high level benefits of 60 gig and compared it to their technologies, I think that I'm hoping it's making sense to you that 60 gig should be an option that you're looking at, both for access or for distribution and backhaul. The return on investment is very attractive, and the ability to meet customer demands for bandwidth and low latency are also excellent. So I'm going to spend the next part of the presentation and look a little bit more into the technology and some of the history of what's going on with 60 gig. So looking back in time a little bit, it was in the mid 2000s when there was an idea to let these certain frequency band around 60 gigahertz to become license free. And the reason for that is that this certain sort of spectrum, right from 57 to 64 gigahertz, is absorbed by oxygen. So it's not a very attractive band to be using terrestrially for any long distance. So initially it was thought that this would be a great band for doing kind of indoor high-speed networking capability, high-speed networking. And 4 channels were initially allocated between the 57 gigahertz and up to 65, almost 66 gigahertz. And around the world, in the US, Europe, and Asia, a lot of countries adopted a portion of this band. Not maybe some channels weren't adopted by some countries. And Peraso was founded at that time with a number of other companies who got involved to develop standards to utilize this spectrum. And to be honest, the first attempts were all involved with trying to do computer networking indoors. And I was involved in that in my first company I was with Wilocity. And it didn't go very well, but it was just with Wi-Fi being as ubiquitous as it is, the urgency to add another frequency band just wasn't there for networking. But Peraso started looking at applications and working with some system vendors and found that if you do the right things and you get the transmit power ramped up as much as you can and you focus the beam in the right with a good antenna gain, you really can do fixed wireless access, and you can get up to 3 gigabits per second. And that started a trend of people developing hardware for this solution. And that was recognized in around 2015. The FCC allocated 2 more channels, channels 5 and 6, which fortunately fell outside of the oxygen absorption band. So you've got these extra 2 channels that are up here, and they're not attenuated by oxygen, and you pick up 17 dB or 14 dB per kilometer of link margin. So that's a big deal. And they also clarified the rules on the antenna, which would allow you to get up to 80 dBm EIRP if you have high antenna gain. So with the combination of high antenna gain and extra transmit power, Peraso created a new RFIC, which has can reach the maximum output powers and also can reach channels 5 and 6. And most of the competitors to Peraso were not able to get channels 5 and 6 to work on their chipset. So this was one big advantage for us moving forward in this market. There was also the creation of 802.11ay, and 802.11ay incorporated some nice new features like channel bonding and a bunch of other stuff that looked good on paper. But in fact, a lot of what's in the 11ay standard is still on paper. It never got implemented. But some of you are probably familiar with the Telegraph system that was developed, and that was a mesh solution based on 802.11ay and incorporating some routing software that was provided through the cooperation with Meta. And that was an extremely interesting solution. It's still on the market today. Peraso did not participate in that effort because we focus more on the point-to-multipoint solution rather than our mesh solution. And we think that we can achieve the same kind of coverage at a much lower cost point for our hardware than what's seen with the Telegraph solutions. Furthermore, one of the advantages that we do have is, again, with channels 5 and 6, we can reach longer ranges, and we don't need a mesh in order to get the kind of coverage that is suitable for most deployments. So some of the good news also is that in the last couple of years, Europe went ahead and approved the same regulations with extending up to channels 5 and 6, and also adopting the antenna EIRP rules. So that allows a bigger market to be addressed. And also South Africa has just announced that they've adopted the same rules for 60 gigahertz operation. So we're seeing, gradually more and more countries expanding this license-free band, and it makes it more attractive for equipment vendors to get into as the market grows. So kind of a summary here again of the features of this technology. We've got a basic technology that uses up to 14 gigahertz of unlicensed spectrum. In one channel, we can get, it's a standard channel is 2 gigahertz wide, and in that channel, we can get up to 3 gigabits per second. If you have an 802.11ay product with channel bonding, you're able to double that throughput, so getting close to 10 gigabits per second. Although, of course, when you do channel bonding, you do lose link margin because of the wider bandwidth. You have low interference because there's no Wi-Fi interference, and also we're using these highly directional beams either by using dishes or by using beamforming. So you're keeping your self-interference very low. We've got point-to-multipoint working quite well with very low latency, giving customers bidirectional capabilities up to 2 gigabits per second, and supporting up to right now 24, and soon there'll be over 30 users per access point. Installation of the equipment is not that tricky. Because of the narrow beamforming and the narrow dish solutions, you will hear some stories that people take a little bit of a learning curve, but pretty much after you try it a few times, anybody can get these installed. We provide an aiming mode in our firmware that facilitates the placement of the antennas and getting them dialed in. So installation is not that tricky. And the cost effectiveness of the hardware, as you can see, there's CPEs that are as low as around $200 to $300, definitely under $300, and some down as low as $100. And then there's access points that can be around $500, which is a pretty attractive price to get started from. I'll say a little bit about the beamforming. I think in general, you guys are probably pretty familiar with this, but in general, when people hear beamforming, they think of Wi-Fi beamforming. As Wi-Fi, it does implement beamforming, but in Wi-Fi, there's a totally different concept of operation, and you do not necessarily get a nicely focused tight beam to optimize your signal strength. It's actually can be quite a distributed beam or several distributed paths that are being summed together on Wi-Fi, and it's very unpredictable in how that's going to affect neighboring equipment that might be on the same channel. With 60 gigahertz, we're definitely doing something like a radar type of dynamic beamforming, where we sum together all of the signal from several antenna elements. And in our case, that can be from 16 to 64 antenna elements. Actually, we've released a new module that has 128 antenna elements. And we're summing together all of that energy into a very specific straight line direction. So we're minimizing side lobes, we're minimizing all that stray energy, and pointing it towards the desired target. And also on the receive side, we're focusing all the energy we're receiving from a very specific direction and not from the surrounding area. So that provides the kind of isolation that you need in order to get very good frequency reuse. I should mention another feature that we have implemented in our systems is that in addition to the standard 2 gigahertz wide channels, we have half channels. And you can see that recently Ubiquiti is planning on doing 1/4 channel. That means a 500 megahertz wide channel. So this of course reduces the total throughput available in those channels, but it gives you the flexibility to implement more and different frequencies for more frequency separation in some applications. Our beamforming operation from our arrays is extremely fast. It's just a matter of microseconds to be able to switch between beams. And so we can do things like fast roaming and switching from customer to customer very quickly. All of these capabilities are basically controlled by the electronics in our chipset, and are leave the host processor free to do handle its traffic and management. For deployment of the systems, you should do planning, but there's a lot of good planning tools out there with LiDAR topographic information. I think it's pretty well-established process of planning out where you place your APs and studying the available topographic data to plan where the access points and the and client devices can go. The the ability exists in our chipset and in our software that if you do have a blockage, that you can set up units as a relay or a repeater, and so that going around corners is basically possible. Going around obstructions can be done with just installing an additional repeater unit or using an existing client node and installing a repeater off of that is totally doable. As I mentioned before, we provide aids for the installation of the equipment, and then also the system vendors on top of us have additional tools that they've implemented to help you look at the signal strength and other metrics in order to determine the best pointing angle. You might be familiar with a contest that Ubiquiti did a couple of years ago. I think it's been a couple of years ago with one of their early 60 gigahertz products that was based on our chipset. And they did a competition to see who could go the farthest. Of course, this was for clear sky conditions. But I think the winner was in Utah, where they did 27 kilometers with and still maintain 900 megabits per second throughput. So it's pretty impressive. Of course, rain fade is a problem. I mean, rain fade does affect the frequency band. And so you do see that the system vendors are integrating a 5 gigahertz backup channel, and even being able to aggregate the traffic between the 5 gig and the 60 gig together to give even more total throughput in good conditions, and then falling back to whichever band is best for any kind of failure condition. I see there's a number of questions piling up here, and my slides are almost done, so I'll get to the questions here in a second. There are link margin calculators available online. I just wanted to show a couple of comparisons. What I'm showing here is a point to multipoint configuration where the access point has 32 element array, which is based on one of our modules, and the clients are using a 64 element array, again, based on one of our modules. So this is without a dish. This is just using our modules as they are. And you can see here on the left-hand side, you're seeing MCSs, or sorry, not MCSs. You're seeing on the vertical axis, the MCSs going from MCS 9, actually, no, so this is MCS 12, all the way down to MCS, I think we stopped it at MCS 2. And actually 2, 3, 4. So actually, no, this is 2. So then you've got MCS, 1 gigabit per second shown here. And then this is the range in no rain conditions. So you're out here on channels 5 and 6, you're able to get close to 900 meters. But then if you take into account rain for region M, and you're looking at 99.49's availability, you have to, discount your range, and you're talking about a little bit less than 250 meters. So that might make sense in a high density area where you don't have, really long ranges to pull. And then you can compare that to a condition where you've got a dish antenna. So here we're looking at a 35 dBi dish on the client devices, and still the access point is with a 32 element array. And now you can see we've got a few different cases here of 2 nines, 3 nines, or 4 nines availability. And I'm looking at channel 5 just to make it simple and not confuse the graph with a lot of different channels. And now we're looking at 4 nines availability, or 2 nines availability. You can look at it 2 kilometers. So that would be appropriate if you have a 5 gigahertz backup. And so most of the time you're running on the 60 gig, but you've got 5 gig backup to handle that blackout time. 3 nines availability of about a kilometer, and 4 nines availability about 600 meters. So again, there's a lot of flexibility in how you can select your equipment, and depending on your rain regions, make the decisions on what's the right amount of antenna gain that you need. So I'll just wrap up here and get to some questions. The main points that I wanted to make is, 60 gigs should be considered as a cost-effective way to provide true gigabit broadband service to your customers. The cost of the equipment and the ease of deployment is very attractive. You've got relatively low power consumption, putting a low burden on your electric for your access points and for your customers. And you've got the ability to approach installations in environments that are really impossible to get to with fiber. So you can handle geographic and municipal issues that you wouldn't be able to overcome with any kind of wired service. The beamforming technology is extremely powerful, and that, combined with some additional antenna gain, makes the ability to handle ranges well over a kilometer feasible. And we have been, working with system vendors, not just Ubiquiti, but others that are getting out there with lots of different options for the hardware you should look into. So let's see. I've got some questions here. They're lining up, but I'll try to go in order. So from Dan, we've got why 60 gigahertz seems never to go narrower in RF bandwidth to meet more distance over bandwidth requirements. Not all 60 gigahertz needs to be very high bandwidth. Seems like the narrowest is still 1 gigahertz, and maybe soon to a quarter gigahertz. So Dan, good question. And then you also asked about MCS 16 QAM. So I think what we're seeing here is that originally the concept of 60 gigahertz was that it would be the 2 gigahertz channel, and it was really kind of a late thought, to be honest, that half channel and quarter channels could make sense. So Peraso did design our chip so we could do the half channel and the quarter channel. It took some time for us to get to the point of really qualifying the half channel, and now we're working on the quarter channel also, along with our vendors. So I don't think we'll go below a quarter channel at this point. The hardware, the filters that are needed in the RF just aren't there in the current chipsets. In a future generation, we could add more filtering and have more selective filtering, but right now there's some hardware limitation going lower than a 500 megahertz channel. In our chipset, 16 QAM is the limit. There is another vendor out there that has the 64 QAM. I think what we've seen is that 64 QAM can be useful in very short range applications, but the hit you take in link margin does become kind of prohibitive to get any long distances with it. So we will have to see that evolve in our chipset for a future product. So spectrum analyzer mode, it's actually on our list of things to do. We have hooks to be able to do that. It's a matter of writing some software to get that in, and to be able to basically take snapshots and be able to process that. So that's a thing we plan to do, and we'll just have to get it into priorities. The slides will be available after the show. Also, if you were at WISPAPalooza, basically these same slides are available, should be available from WISPAPalooza, from WISPA organization. Seems like current implementation using single polarity MIMO. Definitely we're using single polarity SISO. We're not using MIMO. That is an important thing to distinguish, is that 60 gig as implemented by both us and all of our competition is not a OFDM. It's not a MIMO technology. It's a SISO single carrier technology with multiple antenna elements, which are all carrying the same information, but with different phases in order to do beamforming. So it's a kind of a subtle difference, but it's important to understand. And so going to a multipolarization, dual polarization is definitely doable. You're seeing that already being done in the 5G millimeter wave, where they have the dual polarization, and that's on our roadmap for the future. Will Peraso have 60 gigahertz Wi-Fi 6E failover chip, not just 60 gigahertz? So I think Peraso hasn't made any announcements about combining the Wi-Fi, either Wi-Fi 6 or Wi-Fi 7 and 60 gigahertz into the same chip. It's something that we can evaluate, but no decision's been made on releasing a product that has it all built into the same chip. And you got a lot of questions. 82 gigahertz, 80 dBm, and so the limitation for transmit power in the US FCC-based rules is 40 dBm without antenna gain. Our most powerful chip has 16 RF chains, and each RF chain has a P1 dB of about plus 12 dBm. So combined, the conducted power is 24 dBm. And then we pick up the additional gain from the beamforming antenna, combination power of the antenna elements into beamforming. And so the output of the module is essentially 40 dBm. And then that can be increased. That's the limit of what the FCC allows. And then when you add the antenna gain from a dish, you can get up to the 82 dBm. So Next question from Dan was, when narrowing the channel width to 540 megahertz or quarter channel mode, does it also narrow the receiver RF filter to actually improve the SNR? So, ideally, in the ideal world, yes, the narrowing the channel and narrowing the filtering will improve the receiver SNR. There are some implementation losses on that don't allow us to achieve the absolute ideal situation. We haven't done the full characterization of that in order to publish a spec, but that will be coming once we get the full characterization done. And next question was about adjacent channel rejection and receiver selectivity do these radios have? So that's, again, a characterization number that I don't have off the top of my head. If you want to inquire with me after the presentation, we can talk about the adjacent channel rejection for the standard channel mode and the half channel mode. So we do have some very good performance numbers seen with putting multiple units on the same pole, even on the same channel. And so that's doable. Again, that depends on which equipment you select. The Ubiquiti Wave AC, Wave AP has the additional benefit of having a dish, a reflector in the AP, so that helps with any side lobes. And so again, it's going to depend somewhat on how much side lobe power you have and the arrangement of the access points on a pole. All right.
Mike, we have a couple more questions in the queue. I just wanted to interject here. If anyone does have, there's a lot of good questions, a lot of questions that I want to encourage you. If you have some, Mike, you're doing great. Let's encourage. I want to encourage everyone to let's ask Mike some questions. Let's see if we can get some, technical answers out of him to help us get a better understanding of this. So I'll let you go with these next two and see if we get any.
Any support for AP sync to reduce interference? What is currently limiting? Okay, what is currently limiting the supported climb modulations? Will we see 64-256? Is it feasible to achieve 60 gigahertz point to point that can move 10 gigabits per second at 500 meters? So I'll answer the last question first. Yes, it's feasible to do 10 gigabits per second at 500 meters. That's the kind of roadmap that we're looking at for next generation. Doing 64 and 256 QAM. 64 is definitely already has been demonstrated by some of the chipsets that are out there, not by Peraso yet. 256 is doable. I think the limitation with 256 is that you would lose so much link margin that it wouldn't be that attractive. The way to get to 10 gigabits per second is going to be through doing through doing a cross pole solution with having a MIMO on cross pole and pushing the bandwidths up above the 2 gigahertz channel, expanding that a little bit. So it's not that hard to get to 10 gigabits per second, but it would require a next generation chipset that has the cross pole capability. And then, for AP synchronization. So yes, our modules actually already do have synchronization capability built into our modules. That has yet to be used by the system vendors, but I understand that's on the roadmap for the system vendors to employ the AP sync, and then that should help in some situations to reduce any we call them beamforming storms or interference events that can the network. Okay, it says currently, even on the smaller channel sizes, Ubiquiti and the Wave products only has the same number of channels. is there any way to have more channels individually and some sort of hardware limitation? Yes. So that's something that our hardware currently with the half channels can support actually 13 tunable channels. And I'm not sure why Ubiquiti wouldn't be doing that. And then on the quarter channel, I'd have to check and see exactly what would be the number of channels that we can tune to on those. I don't have that on the top of my head.
All right. Well, that was the last question, Mike. So I know there were questions about the slides and the video. I wanted to just emphasize we will send this out. Mike, if you have the presentation, you said you'd share it. We put it together there and include it in our mailer if that's okay with you. But
yeah, that'd be great.
So before we leave, there's Joshua Poole has asked one more question, and I'll let you read that one through and
All
answer
right,
it.
Joshua. Is it possible for a point-to-multipoint single chipset to support multiple carriers? I'm not quite sure I understand that exactly, but in general, the answer multiple channels, um, not simultaneously. It's a single demodulator.
All right. Well, I hope Joshua that helped.
Right.
Mike, thank you very much.
Yeah, you
Look,
can. I'm open to discussion on these things either on Wisp Talk or on directly email me. So that'd be fun to talk with you guys and get more feedback and questions. We're trying to educate the community on the 60 gig and also trying to learn from you guys what you want and what you need.
yeah, it's a growing community of people wanting to expand 60 gig, and I think it's exciting to just hear from you guys, from you, Mike, and and Peraso about it. Here at Streakwave, we have a lot of products that include 60 gig, from Ubiquiti, Cambium to Ciclu. I think it's important that we provide opportunities for people to learn a little bit more about 60 gig, not only from the manufacturer or from the vendor, but from those building the chips too. So thank you, Mike, and we'll look forward to hearing from you again pretty soon.
Okay, well, thank you, Streakwave, Benji, and everyone.
Bye, everybody.